Okay, very, very high chance to come in your exam. 2 essay questions. And lastly, I will answer a few questions which before today, right? Many students actually PM me, send me this question. So when we do free fall, right? Okay, when do we know whether is it vacuum or not? Okay, because in this week, right, I tried some of the questions with some of my students. So their big problem is that they don't know when is it vacuum or not vacuum. So lepas tu, I will also do some types of collision because many students don't know how to differentiate what type of collision. Let's say, for example, is it elastic collision? Is it inelastic collision? Is it explosion? And then lastly, the last part, I will go through types of essay question with you. Okay. Now, anybody got anything that you want me to teach extra before we officially start? No? Can? Jen Yang? Okay? Jen Yang, Liang Yo eh? So Liang Yo never come. Okay, so now, if you guys got no question, all right, then let's do a short countdown. Then let's start. Okay, no problem. Okay, so 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Hello, everybody. Okay, now, guys, now for people who don't know, hi, everyone. My name is Jung Hao. Okay, so I've been teaching physics for like banyak years already. Today, I will cover through the most basic for the first 40 minutes. Then the next 1 hour and 20 minutes, I will do the more difficult question. Okay, just for a warm up. Okay, now let's start with our Suvat stuff. Okay, let's go and see page 6 first. Okay, now on page 6 here, okay, we will have a sprinter doing a 100-meter run. So there will be certain theory questions, but first I want to attract your attention to go and see this question where if the man reaches the finishing line in 12.2 seconds, calculate. Okay, I don't want to do acceleration because acceleration is so easy. Everybody know how to do acceleration, correct? But I want you to calculate the velocity of the man at the finish line. Okay, what we want you to find is the velocity of the man at the finishing line. Okay, so now guys, can look at this question. Now, so if I want to do this, I know that I'm trying to find what is the velocity of the guy at the end of the race. Now, I know that the time taken is actually 10.2 seconds. I know that this is 100 meter. So if I want to find the velocity of this man, guys, can I do it this way? Now, sejak the beginning of chapter 2, we already learned that velocity is actually equivalent to this thing called displacement over time taken, correct? Now, so if I know that the displacement, the total displacement that this guy have to run is 100 meters, all right, if it's a 100 meters, and the time taken is actually 10.2 seconds, can you help me to calculate the velocity is how much? Okay, so let's say we take 100 divided by 10.2. So 100 divided by 10.2, I will get my answer to be 9.804 meter per second. Okay, however, guys, is this method acceptable or not? Can you guys tell me? However, is this method acceptable? Yes or no? Is this method acceptable? Yes or no? So Hao Zhe say yes, this method is acceptable. Xing Long say no. Xu say yes. Chop Yan say yes, yes, yes. Okay, guys, for people who don't know, this answer is not acceptable. Okay, it is not acceptable. Okay, so why? Okay. Now, the problem with a lot of people in the beginning of Form 4, okay, you all have a problem in your brain, whereby because generally you have two types of calculation. Okay, sometimes we have to do speed equals to distance over time taken. Sometimes we have to use velocity equals to displacement over time taken. But then, if you look at another way, in your form 4, you have the S equals to UT plus half AT square. You got all the formulas, kan? Which have a total of 4 formulas. So when can you use this formula? When can you use that formula? So you have to understand when to use which formula. Okay, let me elaborate and tell you this thing. Okay, so actually, right, when we try to choose formula for our calculation, okay, you have to ask yourself, if a sprinter is doing a 100-meter run, is there any acceleration Yes or no? Is the sprinter accelerating? Yes or no? Okay, so guys, let me ask you a question. So if you do a run, are you accelerating? So the answer is obviously yes, right? Correct. There will be accelerating, right? Because when you go for a run, you won't run constant speed, right? You obviously will go faster and faster, right? So this kind of method, which is your speed equals to distance over time, velocity equals to distance over time taken. So this kind of method only works if your object has no acceleration. So the reason why I can't do it this way is because from the start, the guy start running, the velocity is always different. So I cannot take this method. So what is the proper method to do a question like this? So we have to use the four linear formulas that we can find from this chapter, whereby we call it the Suvat method. Okay. So what are the formulas? Where can you find the formulas? Okay, you all can go and see page 1, page 1. Okay, so in some of the schools, your teacher might give you the formula in the exam, these four formulas. But some of your school, maybe your teacher want you to memorize the formula, so they purposely don't give you the formula. All right. So you have to depend on your school, okay, whether your teacher want to give you the formula or not. Okay. Now, for me, I will suggest you to memorize for the first time, but in SPM, if it's in SPM, this will surely be given. So you don't worry, this one surely will be given. Okay, so once we have these four formulas, right, we have to then understand what is S, U, V, A, and T. So S actually stands for displacement, which is measured in meters. U is your initial, V is your final, A is your acceleration, T is your time taken. Okay, so we have these five things here. And then how to know which formula to use that? Okay, so let's go back to the racing guy. Okay, so when we look at this question, we try to pick the informations we have first. Now we know this is a 100-meter run, meaning to say that the displacement that's going to be run by this guy is 100 meters. And if he takes 10.2 seconds to finish, means the total time taken will be 10.2. So you see, I shift all my information and fill this in. Calculate the velocity of the man at the finish line. Okay, why I want you all to ask these questions because I want you all to learn how to differentiate initial and final velocity. Now, guys, velocity at the finish line. Am I looking for the final velocity or the initial velocity? I'm looking for the final velocity, right, guys? Why? Because if you go to the finishing line, that means that you reach the end already. So your finish line is this. Okay, your finish line is V. So now, what other informations do you have? Okay, because if this is a sprinter race, when you go for a run, you always start with how are very good. Your initial velocity will be zero. So your initial velocity will be zero, so you have no acceleration. Okay, if I have no acceleration now, no A, guys, no A given, no A, I have acceleration. The guy is accelerating, but they never give me the acceleration. So which formula should I use? So this is where we will go back to the front part here. We have to list down, you see. Now, every one of these formula have a missing alphabet. Like for example, the first one is missing A, don't have A. The second one has a missing V. The third one has a missing S, and the fourth one has a missing T. So if based on this question, right, I have to use the first equation because I don't have the acceleration. Okay, so oleh itu, when I look at this question, all I have to do is I have to do the S equals to U plus V over 2 times T because here I have no acceleration. Means I cannot use the formula with A. Okay, then what I do next, I sub in everything 100 equals to 0 plus V, divide by 2 times 10.2. I will be able to calculate out my final velocity to be equals to 19.608 meter per second. Okay, so therefore that is my final answer. Okay, 19.96, man. Are you sure or not? Single. Okay, Ken. All right. Now, so therefore, this is my answer. Okay, Ken, guys. So remember, if we ever do this kind of calculation in our exam, it will depend on two things. Number one, okay, if you check the question first, okay, you check the question first. If the question has no acceleration, then okay, you can use the traditional velocity equals to displacement over time, speed equals to distance over time. But however, if your question has acceleration, got acceleration, then your everything will change. You have to use the method of the SUVAT with the four formula. Okay, can I? So you must always check your question got acceleration or no acceleration before you even start your examination question. Okay, don't write formula first. Okay, so usually calculation, right, guys? I'm not worried because my students here, I know most of you, your calculation is okay. Cuma when it comes to explain, because you see, calculation question may be 2 marks, but theory question is 2 marks and 2 marks and 2 marks. So actually, theory question, right, has more weightage in your exam than you think. All right. So let's look at this question first. Okay, the type of attire. Now, so Ivan, why cannot do the upper method? You mean the this one, the displacement, velocity, this one. Okay, you see, right? Okay, Darshan, can I ask you a question now? Now, if we use velocity equals to displacement over time, we are calculating this guy punya average velocity. Okay, if you think about it logically, right, Darshan, when you go for a 100-meter race, are you running at a constant speed? No, right? So that means that your velocity is actually changing, right? Correct? So therefore, if you use this method to count, you are assuming that for this whole entire 100-meter, this guy is running at 9.8 constantly. Is it logical? No, right? Yeah. So therefore, when there is a change in velocity, when there's something going faster, we will assume that there's an initial velocity here, there's a final velocity here. He go faster, and then my initial velocity, I put 0 because you go for a race, you start from rest. So we will assume that there's a we are trying to find the initial sampai the final velocity. So that's why I have to use this method. That's why you see, right, a lot of, maybe like school teachers, yeah, they teach you formula, they teach you the equation and everything, but they never tell you when to use which method. So sebenarnya when you have acceleration, when the object is going faster, you have to do the four Suvat method. If no acceleration, then you can do the traditional, like this is almost your form 3 method. Okay, can I? Okay, very good, Darshan. Okay, now let's go back and see this one, the top part. Okay, so if a sprinter were to go for a race, usually what do they wear? Can you tell me? 来了阵 Eunice, Enqi, Ivan, what do they usually wear if they go for a race? Okay, you don't say they wear aerodynamic. Okay, the aerodynamic is a shape. You tak boleh pakai aerodynamic. Sounds a bit weird lah. Okay. Now the proper way to say this is we will say that they have to wear a tight and light attire. Okay, tight and light attire. The tight to me is more important. Okay, why? Because if you wear like very longer shirt, you have a lot of air to enter the shirt, then you will like it will add additional resistance, right? So therefore, a tight shirt will be able to reduce the air resistance acting on the sprinter. You'll be able to reduce the air resistance acting on the sprinter. Okay. Yeah, and also light means that it's lower mass means he can run faster also lah, which is also a good thing lah. Okay. Then next, what about the type of shoes, guys? What type of shoes should he wear? So understood, guys. Okay, if you were to go for a race, what shoe do you wear? Okay, banyak orang right exam right, they go write sports shoe. You see the how cannot write sports shoe. Okay, they wear a very specific shoe. It's known as spike shoes. Okay, literally the front part of the shoe has like needles poking out one. And if I take this shoe and I whack you, you will die one. Yeah, okay. So you have to be very careful with this thing, okay? Literally, if you guys like whack, you will die one, okay? So why do you want to have spikes in front? Yes, very good. You can say smaller surface area, apa pun boleh, okay? But I will just say that I will increase the pressure acting on the ground. because it is smaller surface area. So therefore, I will be able to increase the grip. Okay, can, all right. Okay, and then now additional equipment. Okay, now so Ivan, you run very professional one, right? You what Roadrunner Marantas Desa champion one, right? So what additional equipment do we have to add for running people? Come guys, during a run, what are the additional stuff that we usually introduce in? The less the better. No need to wear. Lor. Okay, come on guys. Okay, you pernah tengok this thing before? No? Okay, who can tell me what this thing is? Okay, so this one right is for the the when they go for a run, the starting part they will put their legs on this thing one. Okay, why do they want to put their leg on this thing? So because later when the race starts right, it's like boom, then they can kick this one and then they can run. You get what I mean? So they will like kick then you can run faster ma. So the idea is they want to be able to kick the block to move faster. So so this thing is actually known as with a starting block. Now, the point of adding this starting block is so that the runner, the sprinter, can push against the starting block, okay, or you can say he can kick the starting block, all right, so that it will provide a forward force to push forward. Okay, so meaning to say that if you can kick this thing, it will be able to give you like a push forward so that you can you can start at a higher speed. Okay, Joshua, can I? All right. Okay, so therefore provide a force. So guys, this question that you're looking at right now is actually quite a favorite structured question in your exam. All right. Okay, it's quite a favorite style of soalan they will choose in the exam. So make sure you are ready to answer this kind of question. Okay, if you have no problem regarding about this one, okay, now once we know this one run horizontally, next one we're gonna do something that is more vertically. Okay, so I want everybody to go and see page 26. 26. Come on. Okay, can. Okay, so the diagram below shows a ball of mass 100 grams drops from a height of 10 meters from the floor. So what is meant by free fall? What is meant by free fall? Okay, wait, hang on first. Okay, so if exam gives me this question, right, guys, how do I know this guy, right, this ball, right, is dropping in vacuum or not? So what do you think, guys? Is this vacuum or not? Is this vacuum or not? Okay, you go, no, 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 yes, yes, no. Is this falling through vacuum or not? Okay, the answer is yes. Now, how do I know that this is falling through vacuum? Okay, very simple, guys. If today there is air resistance, okay, do you guys know how to count air resistance? Do you know how to count air resistance? No, right? Do you learn how to count air resistance? No, right? So if got air resistance, then how are you going to count the velocity? How long does it take? How are you going to do all this? So guys, remember for physics, right? It's like this one. If they don't say anything, if they never tell you anything, it is understood it is vacuum. The default setting is vacuum. Okay, the default setting is vacuum. Unless they say, hey, then it will be different. Okay, for example, okay, I show you another solan when it is not vacuum. Okay, you can go and see page 13. Okay, let's say, for example, they give you a question like this. So you see here, they purposely tell you that this is in air, this is in vacuum. They purposely tell you that. They purposely tell you this one in air, this one in vacuum. Okay, then obviously, then there'll be difference lah. Okay. Now, I want to test you all. Okay, kalau in air, right, the iron ball and the feather, which one touches the ground first? Which one reaches the ground first? The iron ball. Huh? Wenjun? Air is iron in vacuum shape. Okay, so Zifeng, yes, correct. If we say iron ball and feather drop, of course iron ball will reach the ground first lah. So iron first. Okay. Then feather will be second. Okay. Let me ask you a question. If I test you now, why the iron ball will drop faster? Why the feather will drop slower? What is your reason? You see, you're very bad one. You like to say because the iron ball heavy. Because mass. Okay, guys, the mass is not the main thing. When we see something drop fast or slow, okay, for example, okay, guys, imagine now let's say I got a friend. So my friend is called Junyi. Okay. Then let's say this is me. Okay. So if we compare mass, it's not the main thing. Okay. Whenever we compare falling objects, we want to compare punya stuff is the surface area, bro. Okay. So because your this feather right has a wider surface area, so you will realize that it will block more air. If it blocks more air, therefore this one will be slower. All right. That's why if I compare now in vacuum, when there is no air resistance there. So if there's no air resistance, this both iron ball and the feather, they will reach at the same time. Okay, can Faham Okay, now, so remember okay, now let's look at page 14. I just want you to write the answer together. Okay, now because in your exam, if you see this kind of explain right, 4 marks is going to be the most difficult question. So you will see that top students, they will be able to score this explain because they know what to write. They know what is the answer that's required. Okay, so you see, now we have two different situations here. One is air, one is vacuum, total 4 marks. How can I systematically answer this question? Okay, you all see, so maybe for the air punya, I will explain 2 marks. For the vacuum punya, I will explain 2 marks. So if I add the answer together, then I have 4 EC to write. I have 4 points to write. Okay. Now, so let's explain the observation in both situations first. Okay. Now, so let's just talk about in air. We will say that the iron ball will reach the ground first. Okay, or you can say the iron ball will reach the ground before the feather. Okay. Yeah, that I mean, you can use your own words to 表达 your point to explain what you see. You can say that the ball will fall faster than the feather, the ball will reach the ground first, the ball will drop faster than the feather, all also boleh. All right. Then we try to elaborate. So why we talk about the surface area? We can say because the feather has larger surface area. Okay. So if you got larger surface area, then what? So therefore, you elaborate means that you have larger air resistance. So what will that affect? It will your velocity of the feather will actually reduce. You will have lower velocity of feather due to larger air resistance, due to larger surface area. So we try to use point like pulling each point due to the surface area. So it has larger air resistance, so the velocity decreases, so it will become slower. Okay, then after that, no problem. Okay, then next one, in vacuum. So in vacuum, what should I write? My feather and the iron ball will fall at the same time. In vacuum, your feather and iron ball. Hello, new students. Guys, my writing are a bit ugly lah. Okay, hope you guys don't mind. Feather and iron ball will land at the same time. Okay, can. Next. Okay, so why at the same time? Because you can say in vacuum, there is no air resistance. So you can say both will fall at the same speed, or you can also say same velocity. Okay, Ken? All right. Now, so what do you learn in this example? If they never say, it's understood vacuum. If they got tell you, then you must remember air will have larger air resistance for object with larger surface area. Okay, okay, okay. Now, once you are done with this thing, let's go back and see our free fall question. Okay, page 26. Page 26. Okay, done? Okay, done. Next, okay, let's go page 26. Okay, so now, everybody, okay, diagram below shows a ball of mass 100 gram drop from a height 10 meters from the floor. What is meant by free fall motion? Okay, guys, what is meant by free fall? So these kind of questions are typical exam punya definition question. Now, definition in your 100 marks punya exam, agak-agak berapa markah? Agak-agak about 7 marks. So do you want to memorize definition? Up to you. If you think 7 marks is a lot, yo, a lot, then okay, then you memorize. But if you think 7 marks is very little, then you don't want to memorize. Up to you. Okay. Okay, so we can say that the free fall motion is a falling motion or object that is falling that is affected by gravitational force only. Okay. Meaning to say, if you want to elaborate, you will say without air resistance, just don't have the wind, don't have the air, don't have the foam and all the stuff. Okay, can whether you add the OD noise up to you. Okay, then next, calculate the magnitude of the velocity of the ball as it reaches the ground. Okay, I did this in my normal class, all right, and I did a survey. Banyak orang misunderstood the question one, sometimes. Okay, if they say here, they want you to find the magnitude of the velocity of the ball as it reaches the ground. Okay, since this ball, right, at the end it hits the ground, guys. At the end, the ball hit the ground, right? Can I say that the velocity 0 meter per second? Because the ball will hit the ground. So when the ball hit the ground, then the ball will not move. Then 0 咯，可以吧 ？Can or not? Cannot remember okay, because what they want is the velocity of the ball as it reaches the ground, not after it hits the ground. I want to find when he reached the ground. So I'm looking for the last punya velocity sebelum it menyentuh, like it touches the floor. So which means here I'm trying to find which alphabet, guys. Okay. So here, Darshan, since just now you asked me the question, right? Okay, guys. Darshan, if I want to find velocity, can I do displacement over time taken here? Can or not? Darshan, can. Hey, it's Darshan here. Wait, let me find first. Yeah, Darshan's here. So Darshan, I want to find velocity. So I use V equals to S over T. Displacement over time taken. I got the displacement 10.8 meters. Can I do displacement over time? Okay, guys. Darshan say yes. Darshan. Okay, your object jatuh, right? When your object fall, right? Will your object go faster? Huh? Of course it will, right, Darshan? Okay, it's like for example. Okay, example. If now I drop a stone here to your head, will you die? Maybe you won't die. Maybe you will caught, then maybe you faint. But if I take the same stone and I put it on top and I throw all the way to your head, will you die? Yes, right. Why? Because the higher an object starts falling down, they will actually go faster one, you know. So therefore, yeah, the higher the speed. So when something drops, there will be an acceleration. So we cannot use this lame formula. We have to use the SUVAT Suvat formula. Okay, we have to do this formula, the SUVAT formula. Okay, now if we do this SUVAT formula, okay, then we will see. I want to find the velocity. So I want to find the last velocity when he touches the ground, right? So the final velocity is V. Okay, final velocity is V. Then what about my initial velocity? Drops. Guys, drop. My initial velocity will be, okay, imagine if I hold something, imagine if I drop my phone, if I put my phone like that and I drop it, so the initial velocity will be zero lah. Okay, can I remember? You have to see this kind of words on a drop. Yes, Jian Yang, very good. Okay, across a distance of 10.8 meters, and wait, GG already, guys. I don't have the acceleration. Or do I have the acceleration? Do I have the acceleration? The answer is yes lah, of course, guys. The Earth, this is under something what we call the gravitational acceleration. And how fast is a gravitational acceleration? Berapa? Fixed. Okay, is it fixed or not? 9.81. Is it fixed or not? So the answer is yes lah. Okay, takkan right? Your Earth so free right? Today he tired, then he 9.6. Tomorrow he happy, then 9.8. So this gravity is actually fixed. 9.81 is an acceleration of ms negative 2. Okay, so when I do this, my acceleration here, I will use 9.81 ms negative 2. But guys, please do realize how. Now, my style is my acceleration, I use positive. Why? Because according to my logic, kalau something drop down from the sky, it will accelerate, it will go faster. Make sense? It will go faster. So my displacement, I also put positive. Okay. Now, your faster recall. Anybody here, right? Your school teacher teach you put negative or not? Ada tak? Anybody, faster thing first. Got anybody punya school teacher teach put negative? Got. Okay, got right. Okay. So you must remember this, everything that I teach you today, I will tell you what is the difference between my method and your school teacher method. Okay, so I show you one contour. Okay, according to textbook, 我不会分几时要加几时要减. Okay, very simple. Okay, so if you look at school textbook, okay, if you look at school textbook is macam ini. Okay, korang tengok dulu ah. Okay, so they throw a ball vertically upwards. Gravity, they use negative. Correct? Right. Then when this thing release from a stone, means this one go down, right? Go down. Your teacher also, the gravity, you see this acceleration? They also use negative. Okay, however, I want everybody to put down your pencil first. However, listen up. Listen up. Okay. Your school teacher punya strategy is the A they put negative. Nampak tak? Negative 9.81. But the rule is that their S value also put negative. You see not? 10 meters, but they will sub negative 10 meters. So your S value, both negative. Okay. I ask you a question, guys. Later, negative divide by negative become what? Negative divide by negative become what? Positive, right? So at the end, it will become a positive answer. Okay, my style. So this is school style, textbook style. Okay, Jung Hao punya style is I use S equals to positive, A equals to positive. Positive times positive become positive also, right? Okay, so guys, so which also means now you got two choices. Either you dua use negative, or you dua use positive. Okay, so this is the Jung Hao style. Okay, let me show you guys. So you see now, I use positive S and positive A. So when falling. Okay, now can. Okay, so don't ask go upward first. Don't ask go upward first. We say go down first. Okay, can. So, 小一 confusing 嘛？不会啊？Can understand 啊？Okay, very good. Okay, very good. Okay, now next. Then there's another different style. Okay, so if throw upwards, no need so 麻烦. If throw upwards, I ask you a question. Okay, if now we look at your question first. Okay, if throw upwards, when something go up, it will go faster or go slower. Go slower, right? Meaning to say it accelerate or decelerate. Decelerate, right? So your A, you put positive or negative? Negative, right? Okay. So guys, confusing or not? No lah, no lah. What's so confusing? Okay, can, all right. So no lah, itu saja lah. What's so confusing? Okay ah, get ah. Not confusing ah. Very obvious ah. Crystal clear ah. Okay, very good. So you come back to here. Okay, so now my style is I do two positive. Okay, so no T. Okay, guys, if no T, can you go and see your page one? Tell me which formula do you use? Tell me which formula do you use? Yes, correct. We will use the v square equals to u square plus 2as。可以写减吗？当向下的时候，小偷，可以写减，可以。可是如果你的 a 放 negative 的话，那你的 s 一定要放 negative。if 向下的时候，你一个放 negative，一个没有放 negative，你就错。Yeah. So my style lah, okay, 小东，because right, you see if I want my student to put 两个 negative to put two negative I will worry that they will put one, then forget to put the other one. 就错嘛 right? Then they'll get it wrong 嘛. So I prefer to tell my students, you don't need so lecture, don't need so 麻烦. You straight away use positive. Do also use positive. 这样 I reduce the chance for my student to careless. That is 我的logic Okay, if mommy call you to do two things, sometimes you will do one, forget the other one. Yeah, so 与其做两个事不用做。That's the thing. Okay. Now, so v square equals to 0 square plus 29.81, then 10.8. So finally, my final answer will be equals to v blah 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 meter per second. So what's my answer here? What is my answer here? Yes, so it'll be 14.557 meter per second. So guys, generally we use 3 decimal place 3 decimal place. Okay. Can Okay, so far so good guys. Can I go a little bit faster? Okay, I scared y'all want to sleep already. Can we go a bit faster? Let's go. Okay, so how long does the ball take to reach the floor? So guys, how long does the ball take to reach the floor, right? Some students are very funny one. How long does the ball take? Not try to find how far, not distance. How long means how many seconds. So okay, we will do SUVAT again. We are trying to find the time taken. So according to this Suvat, displacement 10.8 meters because that's the distance traveled, right? My initial velocity is 0, right? My final velocity, I put cross then 9.81. Okay, so I put positive and positive here again. Okay, why do I cross out the V? Teacher, you got final velocity here, right? Why you don't want to use? So people who know me well, like kawan with me, know that I don't like to use the answer above because what if on top, if I get careless mistake, the bottom also wrong, right? So I die and die, right? So I don't use the final velocity, try to avoid using it. So now no V, I can use S equals to UT plus half AT squared. Okay, so 10.8 equals to 0 multiplied by T half 9.81 T squared. Okay, guys. So therefore, I will get, guys, can you help me to calculate how much is my time? It will be 1.484 or 483, right? Sure or not? Not bluffing me, right? 4.484, not 483, 484, okay, yeah, correct. 484 seconds. Okay, so therefore you get that. So we know that when this thing drop all the way to the floor, it'll be 1.484 seconds, 14.557 meter per second. Okay, so the calculation is just this. It's not very complicated. All right. Wow, guys, we very efficient. We did quite a lot of questions. Let's go. Okay, next. If the mass of the ball is double, what will happen to the time taken? Okay, guys. Ding, 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 ding. If the ball just now dropped that time is 100 gram. Now the ball drop is 200 gram double. So what will happen to the time taken? Ah, the time will increase, the time will decrease. Okay, the answer is the time will not change. Okay, guys, don't say nothing happened. Okay, what will happen to the time taken? So your answer must talk about the time taken. The answer is the time taken remains the same, guys. The time taken remains the same. Okay, do you guys know why or not? Okay, so last week's class, so happened we were discussing about this question. So happened we were talking about this. Okay, let me convince you. Okay, guys. If on top, right, my object, okay, how to prove to you that when something drop, the mass will not affect? Okay, yeah, lor, 小姨我就奇怪 why you wrong. Okay, when you're on top, you got this thing called gravitational potential energy. When you drop all the way down, it becomes kinetic energy, correct? So if during this falling motion, my gravitational potential energy will be equals to my kinetic energy, which also means that my mgh will be equals to my half mv squared. All right, so ultimately, you will see that the mass will cancel each other out. So in other words, the velocity of an object, 就是 the velocity of a falling object, depends on gravity and height 而已. That's it. Okay, the gravity, the mass has already cancelled each other. The velocity of an object, the velocity of a falling object is not affected by the mass. In fact, I show you all a very special experiment. Okay, you all listen. Okay, can we use this equation to calculate velocity of the object? Can or not? The answer is yes. Okay, you see, now we know that from the question here, the dropping distance height is 10.8 meters, right? Correct. So we know that the gravity here is 9.81. You see the height is 10 meters, right? 10.8 meters, right? Okay, 10.8 meters, right? Equals to half v squared. You try and calculate. 来，子峰, you help me to calculate this how many meter per second? Oh, you got square root, no? You don't know not lie, you will bluff me, no? Okay, you should get 14.557, which is equals to this one. Do you realize now, if I use the form 3 method to calculate velocity, I will get back the same exact answer as the form 4 method punya. Okay, so by doing this, guys, I've already proven to you that the mass of an object will not affect the velocity. Okay, can I will prove to you that the mass of an object will not affect the velocity. That's it. Okay, the idea is that. Okay, 小聪可以吗 Okay, can. All right. Okay. Now, so the theory part already settled already for falling objects. Sachin, I hope you are able to follow me. Okay, next. So we talk about 这些东西 already. Now I want to do the most annoying part. Okay. So in your coming exam, guys, there are three things maybe very susah one. One of the things that you guys will thorough is explain. The second thing that you guys will be quite thorough at is this thing called sketching. Okay. Now, for example, okay, I test you all this question. Sketch a velocity time graph and displacement time graph for the motion of the ball. Just now, my Mandarin class people say, right, teacher, I see sketch, I straight away skip because I don't know how to sketch. Okay, don't worry. Let's discuss this. Velocity time, displacement time graph. Okay, first one. Let's talk about velocity time graph first. Okay, let's talk about velocity time graph first. We do this one. Okay, whenever we do sketching of graph, right, you must always look back at the motion of the object. So guys, when this object drop down, right, this motion is what? Now I know that my object is going to accelerate, okay, because a falling object will accelerate. So Choyan, really, if this thing drop down, he will accelerate constantly or accelerate increasingly or accelerate decreasingly. Monjin, what do you think? If this object were to fall down, the acceleration is constant, increasing, or decreasing? The answer is the acceleration is constant. Kan tadi we say already, your Earth is 9.81, 9.81, 9.81, 9.81. So the acceleration is constant, right? Okay, it will go constant, constant, constant. It won't go faster and faster and faster and faster. No, it doesn't work that way. Okay, so it will accelerate constantly. Okay, it will accelerate constantly. So now, okay, how if I know that the acceleration is constant, how should I draw my graph? Okay, I actually have two lines to choose. Either I draw macam ni, satu, or I draw dua, like that. Okay, it's like a curve lah. Wait, let me draw nicely. Dua, like that. Okay, guys, which one do you think is the correct answer? Number one or number two is constant acceleration? Zishen, come on, Zio. Number one or number two is constant acceleration. Okay, so according to these two pictures, both of the lines also go upright, correct? Your velocity is increasing. This one, the second graph also, your velocity also increasing because it is also going upright. Okay, Ken, so it's also going upright. Now, but why the answer is one, not two? Why is it one, not two? Because, okay, when we do this kind of graph, right? Okay, guys, promise me, you have to recall this thing first. Okay, gradient of a graph is equals to y-axis divided by x-axis, correct? Which means that my y-axis over my x-axis is actually bersamaan for this graph. Is the same as telling me I'm going to take velocity divided by time. So guys, if I take velocity over time, what will I get? If I use velocity divided by t, v minus u over t, I will get acceleration, correct? Correct. So in this case, since my gradient is going to be the same as my acceleration, so constant acceleration, if my acceleration is constant, that means that my gradient should be constant, right? Okay, how to know something is constant gradient? Okay, gradient in Mandarin we call 斜度. Okay, constant 斜度, constant slope means that imagine if today this guy he climbed this mountain, The line of this is constantly going up, constant slope, constantly going up. But if you look at the second line, this guy, right, if he were to climb, he will get more and more steep, harder and harder to climb. Do you agree? Do you agree? So therefore, which one of this is constant gradient? So this one is constant gradient. This is called increasing gradient. Okay, so the first one is correct. Okay, boleh Okay, you all think sketching difficult? No? Why you all this class like better than my Mandarin class just now? Just now my Mandarin class they say this is so confusing, and then now this class everybody like you also pro already. I thought this is supposed to be harder. Okay, now my can give you one more. Wow, belaga korang. Okay, now. So S T graph. Okay, now, guys, you have to always remember this formula. Okay, the formula is your acceleration of your graph will always affect your velocity. A will 影响 V. V will always 影响 your S, will always affect your S. Okay, can, all right. So remember, if you want to know your velocity graph, you must see your acceleration because your acceleration will affect your velocity. If you want to draw your S graph, you have to check out your velocity first. Okay, so guys, now my velocity is increasing. Okay, now my velocity is increasing macam ni. Okay, so guys, now which is my correct answer? So, wait guys, I erase this number two. I erase this number two first. Okay, so that it's not so confusing. Okay, should my answer be like this or like this? So which one is correct? First one or second one? Now this one. 这个什么问题啊？就是 OK now sketch velocity time graph displacement time graph 嘛。So now velocity graph, okay, I draw already. Now I want to draw displacement time graph. So I give you these two lines. Which one is correct? The first one or the second one? The first one or the second one? Wondering, where is Sean? Where is Sean? Hey, oh yeah, you are Hao Ze. Okay, okay. I told you already, I don't remember Hao Ze, I remember Sean only. Okay, now, anyways, next, okay. So, no wonder like Hao Ze again sounds so familiar. Okay, now next, we see this one and two, okay. The answer for this correct is two, not the one. Okay, why this one number two is correct? Okay, let's try and see. Okay, because now when you draw a graph, you need to think of it this way. Okay, gradient is equals to y-axis over x-axis. Okay, since this y-axis is s, this x-axis is t. So guys, if I take s over t, I will get what? I will get velocity kan. Okay, I will get velocity kan. Okay, so if my velocity is s over t, that also means that my gradient and my velocity is friend, right? So if now my velocity is increasing, if my velocity is increasing, so my gradient has to be increasing as well, right? So meaning to say that when I draw this, I have to draw a line whereby this line is going steeper and steeper. Why? Because this is called increasing grade. So therefore, this is my answer. Therefore, this is my answer because it's increasing gradient. So therefore, this is increasing gradient. Okay, can all right. Boleh Now, can I see a raise of hands? How many of you right think that your school teacher is the very picky, very demanding, very strict? So then when he or she mark your paper, right, they'll be very strict one. Anybody here you feel like your school teacher very strict one? God, 小一、小偷。Okay, okay. If your teacher is the very strict, very 麻烦, very lecture, very demanding one, right? Okay, I will suggest you that when you do your sketching, right, guys, try to label some points. For example, because you just say, wow, you draw like that, you expect me to give you full mark. So, okay, you put in some points that you know. Okay, because we know, right, at 1.484 seconds, the ball reached the floor, right? When he reached the floor, his velocity is 14.557, right? So some teachers want you to mark certain points, right? You write 1.484 seconds. At this point, the velocity will be 14.557 meter per second, and then you write zero here. So if you can write certain points, then your teacher will be more satisfied because you got give coordinate. If you draw like this Saja, right, your teacher say, yeah, why you never label the graph properly? Okay, your teacher demanding, okay, make sure at least you must label the units, okay, guys. So the displacement, right, displacement unit is always what? Meter, time is always seconds, so make sure you remember to label your origin and at what time he reaches the ground, 1.484 seconds. How far displacement, how far is the ground? 10.8 meters, right? So therefore, di sini, it will be 10.8 meters. So therefore, this is my answer. Okay, not can like this, I guarantee you get full marks. Guarantee you get full marks. 100%. Okay, can Okay, if you're okay with this thing, then let's go to the next step. Bring one more step forward. Okay, now yeah, I will skip the impulsive force first because that's not my main aim for now. Okay, I want everybody to just quickly look at page 27. Okay, I know that, right? Most of you, your weakness is at motion graph. Your weakness is at motion graph. So on page 27 here, okay, I don't want to talk about the meaning of acceleration, all this first. Let's talk about the type of motion OA and OB. Okay, let me ask you a question. Biasanya, your school teacher, right, they teach you how to write. Okay, let's say OA like that. Okay, so this is my velocity. So what's the type of the motion of the motorcycle OA? Can I say that it is since the line go up, right? Can I say that this is increasing velocity? Can I write like this? Yes or no? Can I write like this? Yes or no? Okay, OA 许热那也是 constant velocity OA Okay, why cannot write increasing velocity only? Because uniform velocity no the velocity increasing the velocity 在 going up Hi, increasing velocity. Okay. Okay, why cannot write increasing velocity there? Okay, why this one we don't accept Because you technically never tell me properly. Okay, don't forget, Don't forget, If I draw this line, your velocity is increasing. If I draw this line, your velocity also increasing. If I draw this line, your velocity also increasing. So how to distinguish what increasing now? You get what I mean or not? Increase is a general way. You have to tell me how it increase. Okay, so let me teach you a proper answer. Okay. Now you see, I got one student write this answer. Very cute one. See. Velocity increasing constantly. Okay, I paste in the everyone chat here already. Velocity increasing constantly. Is there a way we can make this shorter? Okay, so kita tengok lah. Okay, good try, right? Okay, see Now we know that every time when we want to write this kind of type of motion, right? Can I teach you a secret formula? We will try to talk about the gradient first. Okay, guys, is this constant gradient or is this increasing gradient? Is this constant gradient or is this increasing gradient? So therefore, this is okay, very good. So this is constant gradient. Why? Because the slope is constant. Yes, Hanisha, very good. Okay, so if this is constant gradient, okay, I'm gonna write constant gradient first mentally. Okay, constant gradient. But wait, My gradient here is equals to what? Now, gradient is equals to y over x. My gradient will be equals to v over t. So my gradient will be equals to some more. No, I'm not asking for the calculations. The gradient will become what? Acceleration. Correct or not? Because if I take velocity, I divide it by the time, I will get acceleration. So actually, the gradient word sebenarnya is acceleration. So okay, I can just replace the constant gradient word with constant acceleration. So this is the correct answer. Constant acceleration. Rather than you just say increasing velocity. Actually, I imagine increasing velocity, right? This word is so noob that these two words can combine menjadi one word, acceleration. So we can make constant acceleration. My answer will be even more specific. Correct or not? Okay, can I can do the sigma thing or not? Can okay Then for AB, you can do like constant velocity or zero acceleration pun boleh. Okay? Can so therefore for AB, this one is a bit freestyle because memang there's no change in velocity, right? So you can also write constant velocity, or you can write because flat line, so you can say that there is zero gradient, right? So this is zero acceleration. Okay, can. Now, the lion punya calculation, guys. That one, right? Maybe I will record a video, and then maybe I'll do a video for everybody to watch. Okay, on this kind of motion graph punya lah. Okay, yeah, itu maybe you can follow me on my TikTok or you can follow me on my Instagram or YouTube or whatever. Okay, can. Very good. Okay. Now, so guys, we now 1 hour ended already. Okay, 1 hour plus already. Okay. Like break, not like your break time, but we mentally take a deep breath first. Okay, because we are currently halfway through only, guys. Maybe later I have to extend another 10 minutes. Hope you guys don't mind. Anybody in a hurry after 4 o'clock? No? Okay, because maybe I'll extend until 4:15. Okay, so guys, now after the first round, let's go and see our momentum. Okay, so let's just go back to page 2. Okay, I give you all a mental break. Okay, guys, now let me just predict a bit. Okay, but if I predict correctly, promise me that you will find me and thank me, okay, because I use my power to help you to predict. Okay, now I'm going to guess that your school punya essay question for this time will be around 4 topics. Okay. So the first topic, it will relate anything on sports. So guys, you know what are sports, right? Lompat tinggi, lompat jauh, badminton, tennis, everything, it will be sports related. So you must be ready that they'll ask you some sports punya question. For example, okay, let's just say, okay, they might ask you a question on maybe, oh, you have to design a high jump contest competition. Wow. Then your tila macam mana, everything. Okay, you'll be sports related. So biasanya for sports related, or they want you to design a rugby, how should the person wear for a football match? Usually it will be related to your impulsive force punya lah. Okay, especially they like to ask the tilam. Just like I show you the lompat tinggi punya tilam. Alright. Okay, number 2, they might ask you related to vehicles. Okay, vehicles, they'll ask you either safety features or design a vehicle. Meaning to say safety will be stuff like, okay, like what? Okay, if you want to ask me about safety, here. Safety seatbelt, headrest, tire, e-brake bar, anti-lock braking system, crumple zone, ABS brake also our syllabus. Rubber bumper, airbag, shatterproof windscreen, semua pun kena tahu. Okay, can. Alright, you have to know those. Okay, what about design? So design, they'll ask you certain things like maybe the shape, the tire. Okay, for people who don't know, right? Do you guys know that sports car tire, right, got 花纹, got thread or not? Sports car tire got thread or not? Got 花纹 or not? Okay, the answer is no. Okay, guys, you all see, sports car, right? They use something called slick tires. So their tires are flat and smooth one, you know. Their tires are flat and smooth. There will be no groove, no tread. Tread is the Torah. Okay? Why? Because they want to reduce the friction so that they can go faster. Reduce rolling friction. Okay, so that they can go faster. Okay, I remember. So these are the things that they'll ask you. Okay, selain daripada vehicle, then they'll ask you maybe some momentum punya question. Okay, so what will they ask in momentum? Momentum usually they'll ask you rocket stuff, but rocket, right, guys, got two types. Got the real rocket, the normal one, versus the water rocket. Okay, no. Can the water rocket. So you have to be prepared for all these ST questions to come up. Okay. Now, what is another one more thing that they might ask you is maybe they'll ask you some impulse stuff. Maybe like they'll ask you, do you guys know what is the piling system, the 打地基? Like they'll drop a stone and then they'll hit the pile. So they want to tanam the thing into the floor, like that one, the 打地基 thing. Yeah. So these kind of questions. Okay, make sure you study everything here. I guarantee I will say sekurang-kurangnya satu will kena lah. Okay, can? Okay, can. No problem. Okay, so let's look at momentum. Okay, so now we go into momentum. So every single time when we talk about momentum, right? Okay, before I continue, I want to test because I think this class got quite a lot of new students, right? Okay, so I want to test your logic thinking first. Okay, guys, look here. Now, everybody look at the camera. Okay, let me spotlight my video first. Spotlight. Okay, never mind. Okay, I want everybody to see the camera. Okay, see. Now, my chrysanthemum tea is now on top of my phone. Okay, guys? My chrysanthemum tea is now on top of my phone. If I use my hand and I pull my phone, okay, guys, did I touch the chrysanthemum tea? Can I repeat? Now, I use my hand and I pull the phone. Did I touch the chrysanthemum tea? Never, right? Okay. So let me ask you a question. Did the phone move? Yes, because I pulled the phone. Did the chrysanthemum tea move? Yes or no? I demo again. So if I pull my phone, did the chrysanthemum tea move? The answer is yes lah, guys. Okay, you see if the chrysanthemum tea didn't move, it will be like this lah. Hello. So why my chrysanthemum is here? Why did it end up here? Because it moved with the phone ma. Make sense? So when you sit in a car, did you move with the car? Yes, right. Takkan the car move already, you still behind. If you sit in a car, it means that you are moving with the car. So you move together lah. Okay, can? All right. Yeah, make sure you know this thing. Okay, very important now. Okay, now. So let's just further continue and take out. Okay, we got all these definition stuff. Okay, so why did I ask you that question? Okay, because I want you to see elastic and inelastic. Okay, do you agree elastic and inelastic? Sebenarnya the formula is the same. Do you agree that their formula is actually the same? Okay, I will say it is the same because, okay, you see, if I expand the bracket, okay, if I expand this bracket upwards, you will realize that it will become M1V plus M2V. Because if I expand this bracket, so it'll be M1V, M2V. So it will look, okay, see the front part looks exactly the same. M1U1, M2U2, M1U1, M2U2. The back part also looks very familiar. Okay, the only reason why you can factorize this thing is because for inelastic, they stick together. These two objects are stuck together after the collision. That's why they will share the same velocity. Their v will be the same. Okay, can. All right, okay, okay. So why I say that actually all these formulas in momentum, right, is actually a waste of time. Because if you look at it, right, actually the before and after, their formula is the same one. If you say before and after, the only difference that separates them is is you see, if I say before is equals to after momentum, it completely makes sense because you see this one is initial velocity, this one is final velocity. So when you do your calculation, you just have to remember whatever before will be equals to whatever that is after. These two things will be equals. Equate them together, then you are okay already. Okay, so the most important thing is your before momentum equals to your after momentum. So oleh itu, how to calculate momentum? Okay, I haven't said this thing. So momentum is just mass times velocity. Momentum is just mass times velocity. Okay, can Okay, now let's quickly do two questions. Okay, guys, we are now only 3 questions away from ending our day. Okay, we are now 3 questions away only. Can tahan Boleh Okay, let's look at page 7. Okay, faster guys. Can Today we do so much revision, right? That later when you after this, right, you don't have to study so much. Because How help you to study already. Okay, page 7. Guys, first question. What is the collision that occurs in 4.2? Can I give you some tips? Tengok or not? They stuck together already. Okay, so now, so the collision is what? Because they stick together, they will share the same final velocity, right? So only two, my answer will be it will be an inelastic collision. Okay, it will be inelastic collision. Okay, next. Based on the information provided, calculate the total momentum of the system. Okay, now, so let's continue. Okay, total momentum of the system here, guys. Okay, you see, uh, I try to draw, okay, I try to use the picture and I try to calculate this kind of stuff. Okay, copy first, I paste this image. Okay, can I calculate the total momentum of the system before first? Okay, so let me make it smaller first. Okay, according to the question, they say here is 2,500 kg for the space vehicle. Then the space probe is 1,500 kg. Okay. Now, can I calculate their momentum? Okay, so let's tambah mass times velocity, mass times velocity. Okay, so I'm going to use this mass velocity plus mass velocity. Okay, I know that the 2,500 kg times the velocity 0.5, 1,500 kg times v. Okay, guys, I'm dead because why? Do I have the velocity of the space probe now? Here. Do I have the velocity here? Do I have the velocity on the left hand side? Then how can I find the total momentum? The answer is no, I don't have. I don't have the total momentum before. How? Macam mana? Yes, Tianfeng, very smart. Wow, this Tianfeng got the 水准 Okay. If I cannot find the momentum before, since I know the momentum is before and after is the same, can I calculate the momentum after that? Okay, let's try. Okay, maybe can maybe cannot lah. I tak tahu lah. Okay. Now, so let's try and see first. Okay, since I know after that they're gonna stuck together, and I know that this is going to it's going to be 2,500 kg. This is going to be 1,500 kg according to the question 2,500 and 1,550 I mean 1,500 Okay. So let's add them up together. Let's add them up together. Okay, so the momentum plus the momentum. Now, my left-hand side is 2,500, velocity 0.2. My right-hand side is 1,500, but since they are stuck together, so my space probe velocity will be the same or not? Same, right? Because stick together already, right? Okay. So my final velocity will also be 0.2. So because they stuck together, kalau macam ni, I can use the same velocity. Okay, so now let's try to calculate this thing. Okay, so after I calculate already, I actually get the total momentum to be 800 kg meter per second. Okay, why is it kg meter per second? Because you see, when we calculate momentum, right, very obvious one. Because we use kg, we multiply by meter per second. We use kg, we multiply by meter per second. So when I put them together, it will become kg meter per second, kg meter per second, kg meter per second. So the total momentum of the system will be 800 kg meter per second. Okay, can 800 kg meter per second. Okay, next. Speed of the space probe before docking with the space vehicle. Okay, now, so actually, right, by using the before equals to after, okay, I can actually very quickly do this answer. Do this answer. Okay, now I know that whatever before must be equals to whatever that is after my momentum, right? Okay. So my before will be my mass times velocity, which is my 2,500, because I've already gotten my before here. So it'll be 2,500 multiplied by 0.5 plus 1,500 V, right? Correct? Right? Okay, can. Then I'm going to be equals to, after will be, we already calculate out to be equals to 800. Right, I don't have to do the calculation again now. Okay, so now when I calculate this out, guys, I got satu masalah. My problem is my velocity is negative 0.3 meter per second. Guys, negative logic or not? Rahul, why logic? Negative. Oh. Okay, because we can see here, it is obviously moving in the opposite direction. Remember, your velocity is negative, means you move backwards. Okay, sure, 不是 deceleration not accept, this not A value. A value then different story lah. Okay, okay, so therefore I realize that my V to be negative 0.3. So that is my answer, V negative 0.3 meter per second. Okay, can. Now, so state and explain the principle involved in your calculation. Okay, I want everybody just to check this out. Okay, Jung Hao punya style is I keep on emphasizing my before momentum must be equals to my after momentum. Okay, so some students will be like, teacher, why you teach this one? Macam a bit different from my school teacher. Okay, if your teacher never teach you before equals to after, means your teacher cacat, Okay, why? Because it's literally in the textbook, Okay, you see, as a teacher, right? I mean, for me myself, whatever I teach you, right, I try to refer back the textbook because I know that your teacher will pick everything from the textbook. So every word that I use is exactly the same as the textbooks. Your pernah, I mean, your tuition in Form 1, Form 2, Form 3 as well, right? Your kena this before, no? Whereby maybe your tuition teacher teach you A, then your school teacher say cannot because textbook say B, so must use B. Kena before, no? Okay, so for me, nah, KPM, Kementerian Pelajaran Malaysia. Can here written nicely, total momentum before is equal to the total momentum after the collision. So whatever I teach you is halal dunia, guys. Tak haram langsung. Okay, so therefore it is the principle of conservation of momentum. Okay, principle of conservation of momentum. So means that the momentum is the same. Okay. So if they ask you here, okay, you just write lah, okay, refer textbook TB page 62. Okay, it is actually your principle of conservation of momentum. It's the principle of conservation of momentum. Okay, can so this one describe the proportion of racket, okay, rocket. This one you can refer to this notes punya front part, whereby it's already here. Proportion of rocket. Okay, if you have been a TTC student, you will be able to find this on your notes as well. So they will always say lah, okay, when there's a fuel mixed with air, there will be explosion. You will produce hot exhaust gases. Okay, you will produce hot exhaust gases whereby you will release this gas. Boom. So you produce a momentum downwards. Okay, this is momentum, not mum. Okay, then after that, go all the way up. So you also get a momentum upwards. So these two momentum akan balance. So when these two momentum is balanced, then this rocket will be pushed upwards. That's it. Okay. Okay, can okay, so you can refer to the answers in this page. Okay, so that one I leave it to you. Okay, why don't let's talk about must remember for exam. Okay lah, guys. Of course, you don't have to hafal word by word. Okay, if you ask me, right, how I remember this, okay, most of you here, right, your language can't be that bad. So you got a minimum standard of English, right? Your English can't be that bad, right? So I will remember, okay, so the first point I have to talk about the burning process. So the fuel will mix with the air, then there'll be explosion. Second point, I have to say something pushed down. So I can say the hot exhaust gases are being expelled with high velocity, generating a larger downward momentum. So these are my own words. Okay, so you try to remember the idea, don't have to memorize word by word because they won't mark every word one. They will look for the idea that you're trying to say. They will mark the understanding. Okay, can okay. Now, so once you're done, okay, let's go and see two essay questions. Guys, I promise you all I will do two essay questions. Okay, and these two essay questions, very, 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 very high chance to come out in your exam. So you better listen. Okay. This one, we will do this verbally sahaja. All right. I will write the whole thing, but the last essay question, I will write down everything. Okay, the diagram below shows a water rocket made by a student. So how to modify the water rocket so that it can travel a maximum horizontal distance? Okay. Using the knowledge on the forces. Now you have to say everything here, guys. So let's start. Okay, so when we talk about the material used, so what material are we going to use here? What material? Okay, we try not to name the name of the material. Why? Because you can't name all the material in the world. Like just imagine if I ask you, what do we use to make, let's say, aeroplane? Takkan you name me? It is a duralumin, copper, magnesium, aluminium, composite, blah blah blah. You can't name the number of it, right? Correct. So we usually will describe the material. Describe the material. Okay, so we will say that either you got two choice. Satu, you cakap, we will use low density material. Or dua, you can say that we will use stronger material. Okay, you only have to write one, guys. To write both. Okay, write one. Low density punya advantage is so that it has lower mass, so that it is much lighter. Okay, then what about the stronger material? The stronger material is so that it is able to withstand the pressure inside the water rocket. Okay, because After a while, you're going to pump air into the water rocket. Agree or not? You're going to pump a lot of air into the water rocket. So when you pump air into the water rocket, this thing kalau cut strong, it will boom, it will pecah. So I need this to be able to withstand the pressure. Okay, inside the water rocket. Okay, what about the shape of the aerodynamic? Okay, so okay, I just said the answer. So yeah, the shape is aerodynamic. And why do I want aerodynamic, guys? Why do I want aerodynamic? Because I want to be able to reduce the air resistance. Why? So that I can have higher acceleration. Okay, can boleh ah? Reduce air resistance to increase the acceleration. Okay, like Manas, what is my angle of launching? Manas, come on. What's my angle of launching here? Okay, so guys, okay, Darshan, you are not wrong, but okay, you must depend the question. Okay, some exam question, they want you to launch the water rocket as high as possible. If the aim here is to be as high as possible before it falls all the way down, I'm looking for the greatest maximum height. Then I will launch vertically, right? I will launch 90 degrees. It's like, pew, pew, come down, right? Correct. But if I want this to be maximum horizontal distance, so you better play Angry Bird before, so that when you want 45 degrees, so that this thing can go like as far as possible. Like literally, this one can go as far as possible. Yes, correct. So this angle of launching is actually 45 degrees. Okay. So this one, why? Because it will be able to travel the furthest horizontal distance. Okay, it can move the longest horizontal to travel the furthest horizontal distance. So that is the answer. Okay. Now, then we talk about the volume of the water in the rocket. Okay, guys, this one quite special. This one quite special. What is the volume of the water rocket? Now, some teachers in school, they according to the module, you all use what a module nilam or something, right? Right. Your school teacher. Okay. The answer cacat sikit, you know. Okay, so the volume of water in the rocket, is supposed to be 1/3. Anybody hear your school teacher say half? 有吗 Eunice, 微星, N Qi, anybody school teacher say half? No. Okay, very good. Teacher never teach this before. Hiya, really meh? Why you all always complain your school teacher never teach this, never teach that one? Hiyo. Okay, now, so the volume of water in the rocket is 1/3. Okay. If your teacher, yeah, if your teacher, how to say, if your teacher use module diagram, they say half. Okay, why do we want 1/3? Your teacher didn't come for 1 month. GG. Okay, now, okay, you all understand what is the purpose? Why do we want to add water in the rocket? Why do we add water into the rocket? What is the purpose? Contain air and produce thrust. Okay, the whole purpose of it is because okay, whatever your punya answer or I don't accept why we put water is because when I release, right, I want to produce a backward momentum. Okay, momentum is mass times velocity. So water is heavy or light. Water is a liquid which is very heavy, So if I pump water inside, I can make the mass bigger so that I will produce more down punya momentum. I will be able to produce more downward momentum. so that if I produce more downward momentum, then my rocket will be able to fly with more forward momentum. Okay, I will be able to generate more downward momentum. Then I have more forward momentum, so the rocket can fly faster. But then, why don't we fill more water? Can you imagine if I put more water inside, then my momentum go down even more? Then the rocket go faster lah. Can or not? Yeah. Actually, if you add too much water, you will generate more momentum. Tapi pada masa yang sama, your rocket become too heavy to fly. It's like it's very hard to fly already. Too heavy already. So, so we wanted is so that volume of water is because the purpose is because it is sufficient. It is sufficient to produce larger downward momentum. Produce larger downward momentum and prevent rocket being too heavy. So I too much water, the rocket too heavy. Too little water, I don't produce enough downward momentum. So this is the balance of I have enough backward momentum, but also not too heavy. Okay, can okay. Then after that, we will look at number 5. Okay, number 5. Uh, Sally, your answer 那个 not very good. Wednesday, I tell you why it is not very good. Okay, Wednesday, I tell you. Okay, additional structure. Okay, guys, come on. We still got one more page to go only. So what additional structure must have the water rocket? Okay, if normal rocket, you can detach stage by stage. Okay, stage by stage. But additional structure will. Okay, guys, what are this thing called? Yeah, the tepi. It's not called wings, right? It's called the 翅膀 is called fins. Okay, so why? Okay, imagine if this is a rocket. If your rocket don't have the fins, right? When your rocket fly, your rocket will spin. Means your rocket will rotate. Do you want your rocket to spin while they move? Do you want them to rotate? No, right? Because you will waste velocity, you will waste kinetic energy, you will 浪费 kinetic energy. So cannot My point here is I want to have fins is to prevent rotation of the rocket during flight, okay, or when flying to increase the stability. So I want to make it more stable. I want to prevent the rotation of the rocket during flight to increase the stability. Okay? Ivan, wake up, Ivan. Okay? So how, you all sleep ready not? Okay, now, guys, okay, you all want me to help you pray that water rocket come out essay question not? One not? I have to pray up. And water rocket come out as an essay question in your exam. Yes, okay, I try my best, Try my best, If really come out, you all don't know how to do, you all really, really, really like 对不起 me, Yeah, the answer is already in the 在那个 online. Yeah, 在那个 the website already. Okay, guys, let's go to page 20. Okay, come on, let's go, my guys. Come on, we have 1.5 page more, like 1 page and a little bit more only. Okay, if you're not in a hurry, right, I want to show you one more essay question. I also pray for it to come out. Okay, now, so this is a water rocket. briefly explain what happened to the rocket and everything. Okay, before we continue, just now someone mentioned about explosion. Okay, just now someone mentioned about what is explosion. Okay, guys, you all help me to decide. You all help me to decide. Okay, if one day Junhao is on a skateboard, so I'm on the skateboard, I'm riding with the skateboard 2 meters per second. After that, this is the before. After that, what happened to me was I jumped forward with a velocity of 5 meters per second, and my skateboard actually moved backwards with a velocity v. Okay, with a velocity v. Okay, so while I move forward, guys, is this considered as an explosion? Yes or no? 说了这个算是 explosion or not? Is this explosion yes or no? The answer is no. No. Okay, who can tell me why this is not explosion? Who can tell me why this is not an explosion? 怎么不是 explosion? Yes. Okay, see. Okay, let's look back at the front. Well, this one got study one. Okay. Now, if you look at explosion punya formula, right? Okay, guys, let's see. Okay. Now, actually, right, explosion. Okay, you all see first. Elastic M1V1, M2V2. M1V1, M2V2. Is the ending the same? Is the ending of the formula the same? Yes, right. Of course, the same, right? Correct. Okay. So the only difference between elastic and inelastic elastic and explosion is actually the starting part. The starting part is the only difference. You understand? One is zero, one is not zero. Okay. So the rule for explosion is what? Okay. When we try to look at explosion, now, we bukan tengok the ending part. Explosion must check the initial, not check the final. So I know some of you actually say that, yeah lah, explosion lah, because one object go in front, one object go behind, right? Like that, you kena tipu already. Sebenarnya, it is an explosion because, and it's not an explosion because got meter per second. The rule for explosion is it has to start from rest. Okay, can guys, faster, you got any question to ask me? No, you faster ask first. You got any question to ask me? No, you faster ask first. Because usually, you need to see how to see whether is it, initial, final, this kind of stuff. Jumping off the ground is an explosion. Technically, yes. Okay, no other questions, No other questions, Okay, next. Okay, so okay, guys, this one I don't want to do lah. Okay, what's the meaning of momentum? It's just definition. This is explained. Okay, to save some time, we're gonna straight away go here. Okay, so guys, okay, if water rocket considered explosion or not? Sachin, what do you think? Water rocket considered explosion or not? Obviously, if you launch a water rocket, right, guys? If you launch a water rocket, right, then is explosion lah, because it start from rest, right? Obviously, right? Okay, next. Okay, can you quickly guys do this? The total momentum before the rocket is launched and the total momentum after the rocket, the relationship and everything. Okay, come on quickly guys, come on. So what is my this one? Total momentum before the water rocket is launched. Momentum is mass times velocity. So Xiaotong, today you ask me so many questions, right? 当我问回你问题。So what's the total momentum before the rocket is launched? Mingshen, Kyra, Janelle, Ong, Zihong. Okay, guys, if you try and calculate this thing, I will laugh at you because explosion, so starting momentum, how much? Before the water rocket is launched. Of course, zero lah. What is there to count? Your water rocket starting parking there, right? Parking there, how to move? Where got velocity? Where got anything to count? Correct or not? So therefore, it is 0 kg per second. Okay, total momentum before. Okay, kalau after also 0 kg per second. Do you understand why? Because my total momentum before and my total momentum after must be equal. So if before is 0, my after must also be 0. Okay, very good. So the relationship between C and number 2, you must say that they must be equal. Okay, they just try to trick you. They must be equal. And the principle involved here will be just now what we say, also known as the principle of conservation of what? Momentum. It is the principle of yes, 小姨对的 that is correct. Yes. If you start with zero momentum, 你等下一定是 final also zero momentum. Sure one. Okay. 然后 of course, okay guys, got people ask me, teacher, zero need to write unit. Okay, so I test you back. Is zero a number? Is zero a number? Yes, right. So number must write unit, right? Yeah. Yeah, I'm going to be very honest with you all, guys. Last time, right, I kena in my exam, right, I write zero, then I never write unit. I kena minus mark, I almost cried, because I almost got like A plus. Then, yeah, I wasted that 1 mark. Okay, can next. Okay, what about my velocity of my rocket? Okay, now how do we do this now? Okay, so now I want to find the velocity of the rocket really. Okay, I know that total momentum before is 0. So I'm going to use 0 equals to later punya MV plus the MV, whereby one of these will be the water, the other one will be the rocket lah. Correct? Okay, so 0. And how heavy is my water? My water is, the mass of the water is 0.25, the rocket is 0.1. So my water is going to be 0.25, my rocket is going to be 0.1. Now I want to find the velocity lah. Okay, what is the velocity of the water? So it states here the water is being launched with a velocity of 40 meter per second. Okay, 40 meter per second. Okay, I want everybody to see here. Do you know why I put negative 40 meter per second? Do you know why I put negative 40 meter per second? Yeah, because there they tell me very nicely, right? They say that this thing is launched down. So if it's downward, right? So I put negative. So that if the water goes down negative, then later I calculate my rocket will become positive. It's a backward momentum, it's an opposite direction, right? Yes, very good. So I'll put V, then baru I will count out my velocity to be positive 100 meter per second. So therefore, this is my answer, 100 meter per second. Because I shift forward, I get V equals 100. Are we okay? Can. 元气吸元气 Okay, can understand Okay, now, okay guys, this afternoon, right, got one student ask a question. I think it's very interesting because, right, a lot of people also, yeah, teacher, I also want to ask this same question. Teacher, I also don't understand actually. They ask lah, okay, teacher, why momentum is zero, right? Why the momentum zero? Why the total momentum is zero? But why momentum zero, right? But the rocket got 100 meter per second. Do you understand this guy punya question? Ivan, you mean by the question? Okay, they say that, okay, the guy say, if the momentum is zero, why the rocket can move? Eh? Macam weird, weird, right? Why momentum zero, but the rocket can move? Okay, let's check. Okay, let's check. Very senang one. Okay, because you see, initially, this is the rocket. Okay, this is the rocket. There's water inside. Okay, so initially at rest, everything is 0 kg per second. So the momentum is zero. All right. Okay, after that, this is the before. After that, I realized that the rocket actually fly upwards. Like that. Okay, with positive 10 kg per second. The water go down with negative 10 kg per second, guys. So if I add these two momentum together, how much is my total momentum? Becomes 0 kg per second also, right? Now the reason why it sounds weird is because zero can move because one of the momentum is positive, one of the momentum is negative. Your positive momentum and your negative momentum, boom, at the end become zero momentum. So logic. Okay, they ask, okay, their question is, okay, first of all, Joey, you have to understand the question first. They ask what? They ask, okay, why rocket initially momentum zero, right? No momentum, means no velocity, But why later they can have velocity? Why later they can have velocity? Because you see, after that, your momentum should also be zero, right? That is because one of the momentum is positive, one of the momentum is negative. At the end, when you add the positive and negative momentum, it is still zero. It is still zero. So that is the idea. 就是这样子吧。Joey, okay. Okay, the total is zero. Okay, Ken? All right. Now, so this kind of question quite tricky, whereby they ask you like before and initial the same. This kind of calculation is tricky. Theory, I'm not too worried. The calculation is tricky. Okay, Ken? Okay, now, last part for today, guys. Last part for today, okay. Now, do you remember just now I say, right, like we have those questions very tricky, very, very, very tricky one, whereby the essay question that can come out in your exam, that they will ask you for oil tanker truck. Okay, wait, you'll see here. Okay, this is an oil tanker truck. Can you go to page 10? We discuss only this one. Okay, I will give you the answer. You can write down later if you want to, but I want to discuss everything first. Okay, we can write down one by one. Okay, last page already, finish already. End of this one, then we can end our day already. Okay. Now, so in an oil tanker, right, guys, in an oil tanker, right, how should the compartment of the lorry going to be like? Okay, because dalam your lorry here, you have one container, two container, three container, four container, five container, right? So you're gonna divide them into different tong, right? Different tong, right? Okay, so why do you want to do this? Okay, let me show you my strategy. Okay, I will write like this. Okay, I will write. So the characteristics is we want to divide the compartment of lorry into smaller section. Okay, so we want to make a smaller section. Okay, rather than you just straight away tell me to reduce the effect of inertia, you tell me why I do this will reduce the effect of inertia. like Joshua said we will distribute the mass. Okay, I like your answer, Joshua. Or you can say divide the mass, don't say distribute the mass. So we can reduce the mass in each of the compartment. Okay, I can reduce the mass. Oops. I can reduce the mass in each compartment. So when my mass in each compartment lesser, I can reduce the effect of inertia in each compartment. You understand? So you see, the way I jawab this kind of question, right? I like to say why, the reason, or this one will affect what. Like I reduce the mass, so I can reduce the effect of inertia. Okay, can? So okay, come on, you guys can write this. So we divide the compartments of lorry into small sections, reduce the mass, reduce the effect of inertia. Okay, number two. Guys, what kind of braking system do I want? What kind of braking system do I want? Carbon ceramic brakes? No lah, guys. Okay, there's something called ABS brake, anti-lock braking system. Okay, so ABS is called anti-lock braking system. So some people will just say prevent the car from skidding. Some people just say like that. Okay, I know what. I want to elaborate why I can prevent the car from skidding because uh it will prevent the wheels from locking during braking. So I mengelakkan the tayar daripada tersangkut like that. So I prevent the wheels from locking. I will be able to prevent the car from skidding. I will be able to prevent the car from skidding. Skidding. Okay, I'm not skibidi, it's skidding. Okay, can, all right. Okay, then number three. Number three. Okay, come on, guys. What about the gaps between the truck and the fuel tank? Okay, so when they design this thing, right, do they want to have the gap here to be wider or smaller? So, I mean, bigger or smaller? Bigger. Okay, you don't believe, right? You'll go and see those normal truck lorry, right? The front part of the driver cabin and the thing is bigger one. Yeah, yeah. There are two reasons. If this thing too near, right, the car very hard to turn. The car very hard to turn. The car very hard to turn. Then number two, selain daripada very hard to turn, the gap will also allow the thing that if let's say this car emergency brake, so every one of these thing will fly forward, correct? So if they fly forward, it will accidentally langgar the front passenger, then they will like crash and die. Okay, it will langgar the front, it will make the front part, and then the person will die. So therefore, my answer will be I want to have a wider gap between the truck and the fuel tank. I want to make sure that it's far enough so that it will prevent the load and the petrol tank or the petrol tank. Sometimes it could be load, but in most cases, it's fine to be solutions. No lah, you have a bit of space, so your this object 可以有一个 shake like it can vibrate， so 它不会一直这样弹打下去嘛。Okay, so you will prevent it from terkena the person and then die. So you see that for me, I will explain that first of all, we want to prevent it from crashing into the driver during the braking due to the effect of inertia. So like this, if I write, right, I will write more elaborate, like a longer answer. Okay, boleh Okay, then the fourth part. Okay, so guys, what are the other two things that we can say? Come on, guys, the last part already. Okay, lorry must have what? Extra punya. Very obvious one. You look at this picture, guys. It's like very, very obvious. Okay, okay. How the not the chainsaws? Okay. Obviously, you want more tire than fire. What you want fire for? Okay, why do you want to have more tires? Okay, so some students they'll just say like, okay, your answer will be like, more tire. Then you just write stable. Okay, guys, if you write more tires and then you straight write stable, right? You think your teacher will give you marks or not? You just write this stable. You think your teacher will give you marks or not? Why more stable? Don't lah. Not because if Taya Pancit can replace. No, 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 guys. Okay. The reason we want to increase the number of tires is we want to be able to increase the surface area, okay, of contact. So meaning to say that, I have more tires, I will distribute my force, right? Correct. And at the same time, I will be able to reduce the pressure acting on the ground to increase stability. It's just like, right? Okay, imagine, right? I don't know if guys, right? Let's say Manap, you just imagine. Today Raul wear high heels. Okay, just imagine you all wear high heels. Guys are okay. Do you think you can run with high heels? Cannot, right? Because your leg will be like not stable like that, right? Correct. So therefore, the reason why we increase the number of tires is to increase the surface area, we reduce the pressure, so we can increase the stability. Okay, can Okay, and then the last one, guys. Oh my god, we are at our last question already. Last question already. So, what do we have to add on a petrol tank? Okay, when they refill or when they transfer the petrol, right, guys, they will put something like a chain onto the ground, right? Correct? Or it could be a belt on the ground, right? Apparently, they say you learned this in Form 2 before. Okay. What's the purpose of the chain and the belt? What is the purpose of the chain or the belt? Yes, correct. Is to we don't say to prevent now, is to conduct away the static electricity. Means to say that if you got extra electricity, you want to allow the electricity to flow away or flow in or flow out or flow wherever you want. All right. So our aim here is we try to conduct away the electricity, like move it away, the charges. So see here, we want to add a chain or a belt that is touching the ground and the petrol tank so that excess ions and charges, means excess means extra punya ions and charges, will be conducted to the earth. If you don't want to say to the earth, ataupun you can also say to the ground to prevent sparks from forming, to prevent sparking, so that there'll be no static electricity dan sebagainya. Okay, and you know, right, if you go and refill your car, you will realize that when sometimes, right, they'll call you to touch the car. Sentuhkan kereta sebelum isikan minyak. Next time you and your dad, right, go fill up your car, you go and see the instruction there. They got call you to touch the car. So for you to discharge your charge first. There are chances, there is a chance that if you have static and suddenly you form a spark near a petrol station, you will explode one. Okay, can, alright. You will explode one. Bukan main-main one. Okay, can. No, the whole thing will explode. Or at least catch fire lah. At least catch fire lah. Okay. Okay. Yeah. Okay. Can now. Okay. So guys, how was your this 2 hour session? Okay or not? Is it tiring or not? Great. Yeah. I think we did quite a lot today because I did more than what I thought. I thought today actually I planned to teach about 90%, but I actually teach you all about 110%. Extra a bit, 20%. Okay. So to me, I think it's a good progress, good thing. So if you guys want extra, yeah, if you guys want extra stuff, okay, I think for physics, right, guys, my best advice is you try to do more latihan. No point reading one because you see, whatever we do today, you read also no use one. So you need to be able to do more. Okay, you study also no use one. So do more. The answers is already on the website. You just go to the seminar PDF there and find the answer. If you guys need anything, okay, hopefully you guys can drop me uh, a follow on my social media. Hopefully, you guys can drop me a follow on my social media, Insta, TikTok, YouTube, or whatever. It goes by the handle of Physics by Drew. So if there's a chance, I'll see you guys again in the future. So thank you, everybody. We will sampai sini sahaja. So thank you, everyone. Bye bye. Yeah, Jordan will explode one day if got chop chop. Bye bye. Bye bye. Who Matt Scott? Zishan Matt Scott is it? Yeah. Okay, bye bye.